So up next, we have the founder and CEO of Whiteblock, Zach Cole. He's also a part-time rock star out of LA. Here he comes walking in, crossing the Pacific. Zach's going to talk to us about ETH 2.0 networking. Thanks, Zach.
Thank you. Hello. Do I just hit this button on there? Hello, I'm Zach from Whiteblock. We've been working on networking quite a bit. Most recently, we've been working with the great Matt Slipper on defining the wire protocol. So let's see. So I'm going to go over some of the things we've done and some of our next steps. Let's go over the wire protocol. So the process of defining the wire protocol was a little bit arduous because a lot of people seem to misunderstand exactly what a wire protocol does. It shouldn't really be responsible for like serialization. It should be agnostic mostly to TLS. It's really just a link between two nodes that they use to communicate between one another. You're pretty much just like shuffling bytes. So it's different than an API because it's really agnostic to all that. And then the protocol developer's mantra, that's the application layer's problem. The application should be handling a more advanced logic, but all you're really trying to do is like build a road there. That's pretty much as far as we've got with networking stack in 2.0. There is libp2p, which is the networking stack that was used in IPFS. It's used all over the place. It's a pretty great framework for peer-to-peer communications. We spent a good portion of last year testing Gossip Sub. Unfortunately, a lot of these implementations are still nascent, obviously, so not every client implementer team was able to just use libp2p natively. Prismatic and Lighthouse and anybody that's writing in Go or Rust, for example, they can easily plug and play libp2p, but teams like Artemis and Lodestar, written in JS and Java, can't really use libp2p at the time right now because it requires additional development because the support in those particular languages just aren't available. So rather than being bottlenecked by waiting around for libp2p, we decided that we were just going to build our own protocol for testing purposes only. So we wrote Hobbits, or There and Back Again, which is a reference to The Hobbit. Anyway, so it was lightweight. It's meant to be modular. It's really just for testing purposes. So we didn't make it to say, hey, this is what you guys should do. It's just that at a certain point, as we're developing these consensus mechanisms and these new systems, we're really not going to be aware of how our systems are going to perform until there's a functioning network there. So rather than be bottlenecked, we just used Hobbits. And we implemented it in Artemis, and we're currently implementing it in Lodestar, and we got them all up and running and talking. It took us about a week to develop and implement. It was a joint effort between Whiteblock, Consensus, and also the guys at ChainSafe. Also Dean, I don't know, Dean Eigenman, I'm not sure who he's with now. I think he's with Status. He's just kind of a troll. We got it all running on Whiteblock, ported it over. So Whiteblock is our testing framework. So we're building out 50 nodes with Artemis with 16 validators. This whole process, I kind of just skipped through it, but it like provisions all of the nodes, assigns them to their own VLANs, configures them with IP addresses. And you can see that we do get nodes, and you can see a large array of all of the nodes. You can see each one of them have their own IP address. So they're all logically separated from one another and also separated from one another in like layers 2 and 3, like TCP IP. So everything's running. We got it all up. Everything's gossiping with one another. It's a pretty tremendous feat because I didn't think we could do it, but we did it in like a week. So that was pretty cool. It's not really been battle tested yet as far as the client is concerned and all that additional logic. So we can also offer, well, here's console 1. So you can log into the console on each node and observe like what's happening there. We created Bacon Chain at ETH Paris. This is kind of like a crappy visualizer that we've been using, but it works so far. We really wrote all that code in like 10 hours or so, and it worked. So for the network layer, we can ping between two individual nodes. So you can see there's no network configurations that have been set. So this is just, you know, latency in a box, like an isolated space. So now we can apply different network configurations. So that allows us to emulate links between all these nodes so that that way they actually replicate real-world performance. So you could say like node 1 is in Tokyo or node 1 is in Los Angeles, et cetera, and they'll actually perform in the same way they would. We have a variety of network testing utilities as well. So this is like iPerf. So that's used to test like the quality of traffic between two nodes in terms of bandwidth. This here, we're applying delay. So this is just kind of a basic demo, but we're applying 100 milliseconds of latency between all of the nodes. And then we run WB ping, so you can validate that that's actually working. And yeah, so we have 100 milliseconds. So the idea is we want to observe how consensus mechanisms and how application performance is affected by various environmental conditions, because when you test in a box or in a local area network or like run unit tests, for example, you're really only understanding how that application is going to perform on one monolithic node. But in asynchronous distributed systems like blockchain, it's really important to understand the entire network because it's operating as a singleton. So application performance, when gauging application performance, you really need to consider that. And it's also important because aspects of ETH2 are reliant on time. And anybody who knows anything about time, you know it doesn't exist, especially in a computational environment. So when these issues are actually present and available, things go wrong pretty quick. And so what we want to do next is we want to continue our tests for gossip sub to identify whether or not it's going to be an appropriate mechanism for block propagation or gossiping within the network. Like I said, because timing is an issue, we want to understand whether it's appropriate to use gossip sub because you have a particular amount of time in which you need to subscribe to a particular topic and begin identify your peers within that shard or topic and then begin broadcasting messages that relate to that topic. And if you can't do it in an adequate amount of time, you're gonna find some sort of deadlock or application failure, which is pretty bad. So we really want to make sure that everything works and walk through it and approach this in a deterministic way. We use an iterative process where we identify the metrics we'd like to observe, the environmental conditions that may affect them, and then we apply them in various test series. So that way it's in a controlled manner. So the results are more objective. And we're also trying to find what is the best block propagation mechanism. So libp2p has a lot of this stuff natively. We're working with Protocol Labs on evaluating all of these because libp2p is awesome. But who knows, everything could break, and we don't want to end up in that situation. So we're gonna just take a more objective approach in analyzing and evaluating all these things. We have single client testnet set up now. A lot of people are running them. It's been pretty exciting, but we want to move toward a multi-client testnet because that's when things get really interesting. So I think that we should just mess up everything, break stuff when we can, because it helps us identify the weak points in our architecture and allows us to optimize our design. So let's see. I don't really want to shill Whiteblock here. So, all right, any questions or comments from anybody? Guys, please? No. Yeah, that's it. I just want to keep it short and sweet like me. So, love you guys.